Once again to the Duke William online teaching platform. In this session for performance management, I'll be looking at linear programming, and the question in particular is quite an old question, cut and stitch, June 2010, and of the ACCA examination. It says cut and stitch makes two types of suits using skilled tailor, that's labor, and a delicate and unique fabric called material. Now, both the tailor and the fabric are in short supply, and so the accountant at CS has correctly produced a linear programming model to help decide the optimal production mix. All right. Now, at this point, for exam purposes, like any section C type of question, it's pointless reading the entire question before getting your head around what you are being asked to do here. So, right away, we want to look at what the requirement is. Now, for A, it says find by appropriate calculation the optimal production mix and the related maximum contribution that could be earned by this. So here I can see two requirements. So one is this, and then two is the maximum contribution that could be earned there as well. So it's a two-in-one question for 6 months. Then it says for B, calculate the shadow prices for fabric per meter. So that is also one. And then that's for tailor time per hour. Again, two-in-one there for 6 months. Then it goes on to say that the tailors have offered to work for an extra 500 hours, provided that they are paid 3 times their normal rate of pay of 1.5 per hour. That's the 4.5 there. Um, the requirement for that bit for C is briefly discuss. So in some short sentences, the key verb there is a discussion. So it means the arguments for and against whether CS should accept the offer of overtime at 3 times the normal rate, also for 6 marks. So we need a balanced argument in order to meet the requirement of discuss and to calculate the new optimum production plan if the maximum demand for W falls to 200 units. I like this question because it's a typical linear programming question that could come for this particular, I mean, in this dispensation of CBE exams because drawings are already done and we are to just come out with our figures or solutions given the drawings. So there's no need for a typical graph sheet or something here. So it says let W be the number of work suits produced, LB lounge suits. The constraints we are told is 7W, that's for the tailor's time. So we could call this maybe labor, okay, labor. So if I want to call it labor, yes, fabric, which it says material, 2W, 2L, we don't have more than 1200, which is the line F. So the line F and T is shown in a diagram we can see coming down here. Then it says production of work shoes at the moment, we should not produce more than, so demand will not exceed effectively 400 units, and that is the line P also shown there. I can see P here. All right. Then the objective function. Now, this is needed to work out the maximum contribution. So it means that for every unit of W produced, it generates a contribution of 48, and L generates a contribution of $40 each. Now, on the diagram provided, it said the accountant has correctly identified OABCD as the feasible region and the point B as the optimal point. So then I can say, yes, this is the O, that is the B, that is the C, and that is D. And so all regions inside this constitute the feasible region where the solution could be found. That is at one of the edges of it. All right. So we want to find by appropriate calculation the optimal production mix and the related that Now, looking at the two equations, I have 7W, 7L, no more than 35, and then that as well. So, I mean, going back to basics, if I had to do this, call it on paper, I'll say equation 1 would be 7L plus 5, 7W, excuse me, equal to 35, and then 2W, 2L, 1200, and that should be equation 2 if you want. Now, the object is to find the value of W and L that will satisfy this. So then again, I'm calling this the Taylor or labor, whatever you want to call it. So the Taylor time or labor time, okay, and then the fabric or material, if you want to call that. So the object is to make one eliminate one. So what I could do is I could say equation 2 multiplied by 2.5. The object is if I multiply this by 2.5, I'm going to get another 5. So then this then becomes like 5W plus 5L equal to 5 times this bit there, which should give us no 2.5 multiplied by that. So that is about 3,000, I suppose. Yeah. Now I'm going to use the spreadsheets to do that. So call this equation 3. Then once I subtract this from that, I will now be able to have the L eliminated. So through the method of elimination, I should be able to come out to that. So how do I get this, sorted on the spreadsheet? So let me just minimize this on the side here so that I can work from that. So now it's important that you let the marker know which question you are looking at. So for example, I'm looking at call it equation 1, okay, and I want to call that yeah, let me just so equation. So somebody says, let me call this the equations, and then let's say equation 1, whatever you want to call it. So let's say equation 1. Now, can I just put something like W here? Oops. W here, L here, and then say equal to or equals, whatever you want to put there, so that I can put the equations in there. Don't worry about my spelling there. I won't be worried about in the exam anyway. So I could also put the dollar sign here just to see, work out values. So dollar sign goes up here. So in my first equation, I do have 7, I have 5, I have 3, 500, and that is my equation 1. And so equation 2, that's gonna be 2, another 2, then I have 1200. Very interesting there. So just to bold this so that I don't get confused with this. So these are the two equations I have. I can call this Taylor or labor. So it's up to you. So Taylor or labor, and then call this fabric. All right. Now, so what I'm going to do next is I want to find equation 3. And my equation 3, I can say let my equation 3 be equal to equation 2 multiplied by 2.5. So then I can have this sitting there so that marker can know where I'm getting this from. So I can fix my 2.5 here, then begin to multiply this times that this. Yeah, but you see, I need to fix this. One can just multiply each of them by this and that and that. But if I want to fix it, then what I need to do is I need to put a dollar sign in front of the B and in front of the 7. And when I've done so, I can now drag this there and have all the rest multiplied by. So let me just call this the red one, just give it some color so that you can see. Yeah, so that is equation 3. I now do have 5L and another 5L here. So then it means that what I could do is to now subtract from equation 1, equation 3. So 1 take away 3, for example, is going to give me 7 take away 5. That gives me 2. And then from there, I could just drag that here. So you notice that the L is now gone. So I now have 2W equal to 500. So then my W will simply be 500 divided by 2. So that is that 500 divided by this 2, and I have this. So then I need to produce 250 units of the work series here. So yes, the L. Now that I have the L, going back to the basics, just from this equation, I could figure out the L from here by saying that I have 2L equal to 1200 take away 2W. So then my L is simply 1200 take away 2 multiplied by W all divided by 2. Beautiful. So then this is the equation I'm going to use to find my L, and that shouldn't be an issue at all. So my L will simply be, I don't need to write it there for the marker. The marker should be able to see that in the window. So then I have my L is into brackets 1200, take away the product of W times 2, yes, all divided by 2, and that should give me 2.350 there. So then again, I now have my 350 there given. So then the optimum solution is to produce 250 of work seals and then 350 of lounge shields. But then the question says I need to find the maximum contribution that could be earned. Now, for the maximum contribution, so I can just say max contribution. I'm looking at it is 4840. I can see that there are 48 here and then 40. So what it means is 48 times W value of 250 plus 40 times that should give us this value. So literally, I could work this out by saying my 48 multiplied by the corresponding W value, and then I add on, open up the bracket, 4 multiplied by this, that, and that, and I have 26,000 being my maximum contribution. Very, very, very simple. But then the question says find by, okay, appropriate calculation. So what it literally means is I need to type maybe elsewhere just by this and say produce uh, produce 250 work um, suits and two and 350 lounge suits to maximize contribution, something like that, and obtain a contribution of that. So very simple to do this here. And the next bit of the question, which is the shadow price. Now, what is shadow price? Shadow price is simply the increase in contribution when we have obtained an extra unit of a scarce resource, um, you know, at the original price. Okay. Or the maximum contribution a premium to be paid on top of how much we already pay for a unit of the scarce resource. And then that should we should pay for that. So what we could do is we're going to assume there is one extra unit of Taylor's time hour, and then we finish that, and then we come and work out the extra unit of square meter of fabric. Now, the common error for many students here um, for this exam, according to the examiner's report, was that they attempted to increase all these one by one each because we were to find for both the fabric and the tailor's time. So instead of holding up to one and then finishing one the other, they attempted to work up the entire lot at the same time, which was inaccurate. So what we're going to do is we're going to take increase this by one. Now, the beauty of the spreadsheet is this here. So to start with, again, let the marker know what you're doing. So I'm labeling this as B. Now, am I doing anything new? No, I'm literally going to copy this. So Control C. Now, I'm going to paste it here, Control V. Now, what I see is this. So what I'm going to do is I'm going to change that figure to 1. So 3,501. And then immediately I can find that the tailor's time is now, so the tailor's time, which means that a new contribution that, so then I can find shadow price, okay? So I can work that here. Shadow price, shadow price, or let me just say shadow price. I'm going to do that of um, Taylor's time will simply be the increase in contribution. So you see it's 26,004 here and 26,000 originally. So the difference is what gives me the shadow price. So this take away the original contribution, and that is the shadow price. So that is the maximum, and that could be n. Now, if I want to find the shadow price, so maybe I should label this as shadow price for the tailor so that it becomes clearer. So then if I want to find the shadow price for fabric, I'm going to take the original equation again. So watch, I'm cutting the original equation, Control C. I'm coming to paste it down here. So Control V, I have it here. But this time I'm talking fabric. So I'm changing the fabric to 12,001, keeping the 3,500 intact. Oh, what a beautiful thing spreadsheet is. Immediately, I have the maximum contribution to be earned at that point. So then shadow price, again, will be the difference in contribution, which is this contribution. Don't forget, it's the original one, which is this one. And I have 10. Very beautiful. Very, 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 very beautiful. So 4 and 10. Let me just make this, give it a bit of color so that you can appreciate what is happening here. So shadow price for the fabric is 10, and it represents the maximum contribution, or sorry, the maximum premium that could be earned as a result of obtaining one extra unit of the scarce resource, be it the fabric or the tailor's time at the original price. Now, interestingly, so you see the spreadsheet actually makes, so once you are able to line up your equations very well, and they are all, the cells are well related, you can just copy and change one at a time, and it gives you the different variables, change one at a time, and the rest will fall through. Very, very beautiful here. Now it says briefly discuss whether the company should accept the offer of overtime at 3 times the normal rate, 3 times the normal rate. Let me just pick um, a word processor here. So this is what you should expect, a word processor. Okay, so let me just assume I have that here. So then again, I'm looking at C. So C is likely to be in this form. So whether the offer of what, so I'm talking offer of overtime. It's a brief word discussion. And so discussion means the arguments for and against. Now, to start with, what do we know as a shadow price? So one can say, all right, shadow price or dual price represents the increase in total, the increase in total contribution as a result of obtaining an extra unit of the scarce. Um, so let me just expand this so that you can just say the scarce resource at the original uh, price. So at least you have been able to demonstrate what it is. But then what is the whole thing about? Now, it could also be as also I think I want to go the second way, also expressed um, um, as the maximum premium to be paid on top of how much the scarce resource is paid for something. So what it means is if you go back to the question, you can see from here that it says at the moment we are looking at, it says if whether you should accept the offer of 3 times the normal rate. So they are paid 3 times the normal rate. And what is their normal rate? Their normal rate is 4.5. And when we worked out, um, you know, when we worked out the shadow price, you will notice that the shadow price was given as 4. So the shadow price of this was given as 4. Now, so if it is 4, I'm trying to, okay, know where my pen wouldn't write. Okay, so never mind. So then it means that the maximum premium, I'm talking about 1.5 plus a shadow price of 4, giving me 5.5. Just bear with me. I'm trying to use the cursor to write because my pen is playing now for whatever reason. I don't know. It stopped working. That okay, yeah, it's working. So 1.5 plus 4 giving us 5.5. When this then becomes the maximum payable. Okay. Now, so if they are asking for 4.5, it is still within the maximum, meaning that we can afford to pay and still make some extra returns. So the arguments for, so this is what you're doing here. Okay. So at a shadow price of $4, the maximum payable will be equal to 1.5 add on add on 4 equal to 5.5. Okay, suggesting that the their asking price of 4.5 is, call it affordable. Okay, so it's affordable. Okay, and can be paid. So just make sure you understand what is happening here. The maximum we can pay, we can pay is 5.5, and they're asking for 4.5, and that sort of makes sense that we can afford, and so we should. So what I'm trying to do here is, within that, I'm looking at an argument for this. Okay, it's affordable, so we can pay for it because it's still less than the maximum payable. So the shadow price, don't forget, represents the maximum premium, no more than that. All right, now the argument against that has to do with um yeah, one would say um tiredness and its impact on quality. So what it means is, they said they are available for extra 500 hours because we don't seem to have enough. All right. Now, so if we don't have enough, then they would want to do extra 500 hours, but then they want to charge 3 times the price. So what we're looking at is, isn't it possible that when they have done more than they normally do, they could get tired, and that could impact on quality, and then hence the reputation of the brand. So you are looking at something like that, and that is probably the reason why we should be careful for paying that. And then also, um, the company could negotiate for um, maybe a time and a half, or a half, or probably double, you know, double time, as it appears to be a bit on the high side. So they can negotiate and come for a time and a half and say, we're giving you maybe 1.5 and a half, and they'll double time $3, which is still well below, because you see, it doesn't take time for human beings normally to ask for more once they've settled at a particular price. So the 4.5 they're asking for is affordable financially, which we should pay for. But then, we looking at its impact on, the quality or the finished product, because you see, these are fabrics and human beings need to work on, and they get tired, they're bound to make mistakes, and that could affect the brand as well. So it said briefly, and briefly will mean that it has to be brief as well. So that is essentially what you are talking about here. Then the last one says, calculate the new optimum production plan if maximum demand for W falls to 200 units. So here I'm going back to the diagram to see what exactly that means. So let me just change the color here. We are done here and see. So the maximum for W was 400. Now, if it falls to 200, where this 200 is, then it means that this line will move here. The line P will now come all the way to 200. Now, at 200, then it means that the optimum point now rests between the point P. So it's now going to be the point P, the line P, which is a W of 200, and the line F, which is the fabric, which is 2W plus 2L equal to 1200. So these are the two equations we will need to solve. Now find a new optimum production plan for when the demand for W now falls to 200. So then the P line moves to the left, and as you can see, as it moves to this, take it up there, it literally just comes to this point here. So let me call this maybe B2 or something. So I'm now going to solve these two equations to arrive at that bit there. So yes, going to my spreadsheet there. So then again, the requirement there, you got to label that. What's the requirement? It's important that the marker is, so it is D. So you go there and pick out this as D. It's important. So with D, you know that's your W already given there as 200. So W is given as 200. Nothing to worry about there. But then the new L, as you can see, looking at this will mean that I'm literally going to find this equation. All I need to do is to demonstrate that it is going to be these two new equations that is going to be replicated there. So yes, I can literally just go back and say, okay, I have this. There is an equation here, which is the tailor's time or the fabric time. So why not? I can literally just pick that and bring that here. So equal to, so look at what I'm doing. I'm referencing that. And once I have that, I would want to imagine I should have a sitting there. Yes, it's coming here. Okay. So I'm solving. So I might as well delete this and that. So I have my W, I have my L, and then I have a W of this. So what would that L be? That L will simply be, we've seen this already, equal to, so watch, 1200 take away 2 multiplied by a W of 200 divided by 2, and that should give us 400. So let me put a W of 200 here and reference it. It's always best. So I would want to do this again, equal to 1200, take away into brackets, or yeah, I don't need a bracket, this multiply by 2, all divided by 2, that's give me 400. So yes, the optimum production plan, and that's it. Question finished. Should be, they should now produce 200 units of worksuits and 400 units of that, and that's it. And that does it for this question. So the spreadsheets actually makes life much easier here. Thank you for watching. I know I'll see you on the next video. Do well to subscribe to this if it's available on YouTube.